Hello and welcome guys into a new chapter. Welcome to Gaussian closed surface. Gauss law consider a hypothetical or imaginary closed surface, or what is called Gaussian surface in closing the charge distribution. The Gaussian surface mimics the symmetry of the charge distribution. So let's start by explaining what a closed surface means. For Gaussian law, we are going to to evaluate the electric flux through a closed surface, like the surface of a balloon or a soda can or a cube, or just some imaginary surface like space, like this. So, to calculate the flux, you have to break your surface into a little patches and integrate all the small fluxes through each little patch. Of course, any surface can be thought as the sum of the bunch of little patches. Just imagine taking about a surface and drawing a little grid on it, completely covering it. Each tiny patch will have a tiny area called dA. So the flux through a closed surface is the sum, really integral, of the flux through all patches covering the surface. The convention is always that dA points everywhere out of the closed surface. We write this flux formula or net flux formula as the following formula. A flux equal integration over a closed surface E vector dot dA vector. The weird circle around the integration is to remind you that we are talking about integral or sum all the way around a closed surface. In a crude sense, flux counts how many field lines price out a surface. In this example, it's required to calculate the electric field, so we have to divide the surface into three areas: area A, area B, and area C, as shown in the figure. To solve this problem, we have to integrate over a closed surface. This surface is divided into three parts, as I mentioned before, so we have to integrate over the three parts. Starting from part A, cosine theta is -1, since the angle is 180 degree. Then the integration is equal to minus E times A, where A is the area of the circle that is equal to pi times radius square. Moving to part B, cosine theta is 0 since it's perpendicular, so the answer for the integration is 0. Finally, part C, cosine theta is 1 since the angle is 0 degree. Then the integration will be equal to E times A. Finally, finding the total flux by adding the three previous integration will get 0. Consider this example. It's required to find the total flux in the cube. Knowing that the electric field is uniform from left to right, then the only two sides of the cube will experience a flux. The other sides will be perpendicular to the field with zero flux. On the sides that experience a flux, there will be equal to minus EA and the other will be equal to AA. So the total flux will be 0. This is the end of the video, guys. I hope that you enjoyed and get benefits from it. Please don't leave without a like, a comment if you have a question, and a share. Also, if you don't subscribe yet, please do it now for more interesting topic in the future.